Hi everyone. In this video I'm actually going to be talking about two things. Okay, the first half of the video is going to be taken up for Pythagorean triples, and in the second part of the video I'm going to talk about something called the triangle inequality. Okay, so what is a Pythagorean triple? A Pythagorean triple is a set of three positive integers that satisfies the Pythagorean theorem. And just a reminder that integers means whole numbers. Okay. So what you might have observed in doing a lot of Pythagorean theorem problems is that usually we end up with some not so nice square root as either a, b, or c. So when we can find a set of three whole numbers, that's actually pretty special. And those sets are called Pythagorean triples. So examples of Pythagorean triples are 3, 4, 5, and 5, 12, 13. Okay. How do I know that 3, 4, 5 is a Pythagorean triple? Well, if I use these numbers as a, b, and c respectively, and I plug into a squared plus b squared equals c squared, I'm going to see that 3 squared plus 4 squared should be equal to 5 squared. So 9 plus 16 should be equal to 25, which is true. Okay, so 3, 4, 5 is a Pythagorean triple. What about 5, 12, 13? Well, once again, I'll write down the equation of the Pythagorean theorem. I'm going to substitute 5 for A, 12 for B, and 13 for C. So 5 squared plus 12 squared should equal 13 squared. 25 plus 144 should equal 169. If we work that out, 169 is 169. So 5, 12, 13 is another Pythagorean triple. Okay. Now, it's important to note there are an infinite number of Pythagorean triples. And one of your questions on the worksheet is to go out and try to find another one. In class, we're going to discuss other ways of finding Pythagorean triples and how knowing the Pythagorean triples will make Pythagorean theorem problems much easier. The next topic that we'll cover in this video is the triangle inequality. Okay? Now, the triangle inequality says the sum of any two sides of a triangle, and this is any triangle, okay, not just right triangles, must be greater than the third side. So what does that mean? Well, let me just draw out a quick triangle. For this example, I'll just use the 3, 4, 5 triangle that we just talked about, which is a Pythagorean triple. But just keep in mind that this works for any triangle, not just right triangles. And I'll see that if I take any two sides, like the 3 and the 4, and add them together, that's actually greater than the third side, 5. If I take two other sides, let's say the 4 and the 5, that's greater than the side that I didn't add together. And finally, if I add 3 and the 5 together, that's greater than the 4. Okay? The reason why this is called the triangle inequality is that if I choose any two sides of a triangle, when I add them up, I should get something that's greater than the third side that's left over. Okay? Let's see how you use that fact. Can the lengths 3, 4, and 7 be used to create a triangle? Okay? Now, it's probably best to see kind of a visual demonstration for this. Okay? So here, what I have is a side with a length of 3. So up here, 1, 2, 3. Over here, I have a side with length 1, 2, 3, 4, and this line on the bottom has a length of 1, 2, 3, 4, 5, 6, and 7. So 3, 4, and 7. So the question is, can I put these lengths together to form a complete triangle? And if using this program, I can try to move these legs around to see if they'll touch. And you'll notice that they always just kind of barely miss each other. Okay? And because this is length 3 and this is length 4, and 3 plus 4 is not greater than 7, it's actually equal to 7, the only time they're actually going to meet up is if they're lying right on top of the last line. Okay? And that doesn't really count as a triangle. So the answer to this question, can the lengths 3, 4, 7 be used to create a triangle? The answer is no, okay? Because 3 plus 4 is equal to 7. Okay, and from the triangle inequality, we know that if we add any two lengths, they have to be greater than the third. Let's take a look at another question along these lines. Can the lengths 9, 12, 15 be used to create a right triangle? Okay, so I'm not just asking whether or not they can be used to create a triangle. I want to know if they can be used to create a right triangle. Now, 9, 12, 15 can definitely be used to create a triangle. 9 plus 12 is greater than 15. 9 plus 15 is greater than 12. And 12 plus 15 is greater than 9. So yes, it can be used to create a triangle. Can it be used to create a right triangle? Well, to be a right triangle, these three sides must satisfy the Pythagorean theorem. Okay, so I'm going to write down a squared plus b squared equals c squared. Okay, now just pause for a moment and think to yourself, how did I know to label these a, b, and c, other than the fact that they're just listed in order and it might seem logical to label them a, b, c in order. We know that in a right triangle, it doesn't matter what we label a or b, but we know the hypotenuse is along the side, so I definitely know that 15 has to be the hypotenuse, if this could be a right triangle. Okay, so plugging into the equation, we have 9 squared plus 12 squared, and we want to see, we're not sure whether or not it's equal to 15 squared. 9 squared is 81, plus 12 squared, 144. Does that equal 225? Okay, if we add these two together, indeed, in fact, 81 plus 144 is 225. So the answer to this question, can the lengths 9, 12, 15 be used to create a right triangle? Okay, yes. Okay, and our proof, our reason is above in our work here. Okay, and in fact, what we've discovered here is that 9, 12, and 15 is another Pythagorean triple. Okay, so there's another one. One last thing to discuss is a very common mistake in algebra. Okay. A lot of students, when they see the equation a squared plus b squared equals c squared, want to automatically write a plus b equals c. And that seems logical because I'm square rooting c, I'm square rooting b, I'm square rooting a. It seems it should all work out. Okay. What we talked about in this video with Pythagorean triples and the triangle inequality should give you a good sense of why this is not true. Okay, just because a squared plus b squared is equal to c squared does not mean a plus b is equal to c. Okay, so my reasoning for this is to think about, first of all, the 3, 4, 5 right triangle, the Pythagorean triple. We know that 3 squared plus 4 squared is equal to 5 squared, the Pythagorean theorem tells us. And 3 plus 4 is obviously not equal to 5. Okay. Another reason is to think about, well, let's say we have any triangle where a squared plus b squared is equal to c squared. Okay, so any right triangle. By the triangle inequality, if I add any two sides together, they have to be greater than the third side not equal to. Okay, so something to keep in mind for the future while you're doing work in algebra. If you know a squared plus b squared equals c squared, okay, don't rewrite the equation as a plus b equals c. All right, okay, that concludes this video. Have a great night.